Hello, in this video we are going to discuss about how to prepare alcohol using organometallic reagent. Whenever we say the organometallic reagent, these are the reagents that consist of organic group bonded to the metal. Okay? Organometallic means organic group bounded to the metal. And in such type of the reagents, in organometallic reagent, since the organic group is bounded to the metal, this organic group will be usually negative, or R group will be negative, because metals that always will be kind of electropositive ions. They will form the electropositive ions. So metals will be positive, whereas the organic group will be negative. Because of this negative carbon containing organic group, these reagents are very reactive and can produce varieties of product. And among those, the alcohol is one very important compound that could be synthesized by using such organometallic reagents. Now, there are different type of organometallic reagents that is in use for the preparation of alcohol. Among that, the first one that we will be discussing about, we call that as sodium acetylide reagents. Sodium acetylide reagents. The sodium acetylide reagents originates from what we call terminal alkyne, RC triple bond CH. Right? Whenever you have the hydrogen in one of the terminal carbon in alkyne, we call that as the terminal alkyne, and the sodium acetylide reagent originate from this terminal alkyne. As you all must be aware that in this type of terminal alkyne, this terminal hydrogen is somewhat or slightly acidic with pKa value very close to 25. So this hydrogen is somewhat acidic with the pKa value of nearly 25. And this type of hydrogen can be deprotonated by using a very powerful base. And among that powerful base, one very important base that you need to memorize the name is sodium amide. This is called sodium amide, right? The ordinary base like sodium hydroxide, potassium hydroxide cannot deprotonate this acetylenic proton. For this, you need a very powerful base like sodium amide. Now, in sodium amide, sodium is slightly positive and this amide is negative, right? This is sodium is positive and negative, and that negative amide group will able to grab the proton, will generate the negative on the carbon. So that is how we generate RC triple bond C with the negative. Now, when this carbon has negatively charged, then this sodium will get the positive, will sit next to the carbon. So this is what we call sodium acetylide. And of course, this amine has grabbed the proton, so ammonia will be the side product. Now, this sodium acetylide generated in this way is a very strong nucleophile with the negative charge on the carbon. This is a very strong nucleophile. And this strong nucleophile can attack on carbonyl compounds. The carbonyl compounds can be either aldehyde or ketone. Say, for example, a C double bond O. We call that as the carbonyl compound. Now, whenever you have some kind of group, say R and R prime, you can take this as an example of ketone, right? So in this ketone, in this carbonyl compounds ketone, the oxygen will be slightly negative, carbon is slightly positive. is a polar. So now this acetylide, this organometallic reagent, that is acetylide, is very powerful nucleophile that will go ahead and attack on this carbonyl carbon, which is slightly positive, and it will generate the negative charge on oxygen. So now you need to draw the product. That is where the students usually get very confused. So I strongly recommend you to follow step by step process to draw the product. You see here, this negative charge is attacking on the carbonyl carbon. So you can draw the carbon as it is, which has got R group here and R prime here, R prime, and now oxygen is single bond with a negative charge, and this all RC triple bond C group is attached to the carbon. So this is RC triple bond C is attached to the carbon. That is how you get the anionic product. Now this sodium will go and sit next to the carbon negatively charged oxygen. This is how you draw the product. Again, please check that this group is attacking on the carbon. That is what is attached on the carbon. So you need to have a good practice on drawing this kind of product. Now we do not isolate. This is the salt with the O as a negative and sodium as a positive. We do not isolate this kind of salt as the product. So we need to work up. And normally for workup, we take some kind of acid like a hydronium ion. You can use that as a acid workup. Then what does it do is this O minus will grab the proton from that and it will generate the alcohol RC R prime, and here you have it as RC triple bond C, and then now O minus will generate to OH. So that is how you get the alcohol as the product. So in this way, and the other side product will be sodium hydroxide and all other, but this is the alcohol product. That is how we generate um, by using the sodium acetylide reagent. Now, one more point to be noted is here the type of alcohol depends upon what type of carbonyl compound so we are using, right? We have a different type of carbonyl compounds. So if we use this carbonyl compound, for example, as a formaldehyde, you have C double bond O. If you have both side hydrogen, we call that as formaldehyde. If we use formaldehyde and react with that sodium acetylide, C minus and Na plus, so this is what is going to be attached on the carbon. So the result will be carbon with two hydrogen, O becomes now OH. This is where you are attaching this entire acetylenic group. So RC triple bond C, that is what will be attached to the carbon. Now see, the alcohol that is generated that has two hydrogen on the carbon, and the one is R group. So you get the primary alcohol. So if we use formaldehyde, we generate primary alcohol. Now, if you use the aldehyde other than formaldehyde, say for example, RC double bond OH. So this is like a other type of aldehyde other than formaldehyde. Then again, if you use this acetylenic group there, and react with this kind of other aldehyde, the result is going to be carbon with R and H, and this O becomes now OH, and you have attached again RC triple bond C group that will be attached there. So that is how you generate now will be second degree alcohol. But if we use the other one, let's say for example RC triple bond C negative and Na plus, and you react with like a ketone, R and R prime is a ketone, then you can see that the product that is generated as you saw previously. Again, this is the group that will be attached now to the carbon here, and the result here will be the tertiary alcohol. Okay, here you have RC triple bond C group is attached to this carbon here, and OH, that will be 3-degree alcohol. So the sodium acetylide, if it reacts with the formaldehyde, will generate primary alcohol. If it reacts with other aldehyde, it will generate secondary alcohol. And if it is reacted with the ketone, that will generate tertiary alcohol. So that is how we uh, uh, produce the alcohol by using uh, sodium acetylide as the reagent there. Okay, so this is what we use sodium acetylide reagent. That is number one. The other one, that second one, is a very, very powerful reagent. Number two, that we call is the Grignard reagent. Grignard reagent. And along with that, we will connect that also with the next is the organolithium. And why I'm connecting these two, both will behave in exactly the same way. Grignard reagent and organolithium will connect at that will act in the same way. So first of all, we need to understand here is and by the way, this is a very powerful reagent. Also, this is the Nobel Prize winning reagent, Grignard, who discovered this reagent, got the Nobel Prize for the discovery of this reagent. So it's a very, very important one. And organolithium also behave exactly in the same way as Grignard reagent. So we will discuss that together here. So the Grignard reagent is the magnesium containing reagent. So here normally Grignard reagent we define as R, or the alkyl group connected to magnesium and some kind of halogen. Halogen usually chlorine or bromine, that is the halogen. X is equal to chlorine or bromine, that is what we normally use, chlorine or bromine. And R, the R group that is attached to the magnesium, this can be either alkyl group or aryl group. That is how we call that. As aryl means it's the benzene ring, right? Aryl group, the benzene ring, or any alkyl group can be attached to the magnesium. This type of reagent is called Grignard reagent. For example, R group can be like CS3, CS2 ethyl group, which is attached to magnesium, and X can be, let's say, chlorine. So ethyl magnesium chloride, this is one example of Grignard reagent. Or we can use that R group as the, for example, is a benzene ring, which is attached to magnesium and bromine, for example. Instead of chlorine, we can use bromine. So this is other example of Grignard reagent. So on the other hand, the organolithium are the reagent that in which the R group is directly attached to the lithium. So here in Grignard reagent, the metal is magnesium. In organolithium, the metal is lithium. And remember that magnesium is bivalent, is with the +2. That is why you have to have one halogen there. Whereas lithium is group 1 metal, it is monovalent, so it is one positive, so you do not have any halogen attached to the lithium. So RLI, we call that as organolithium. In both type of reagent, again, since R group is attached to the metal, like we saw that in sodium acetylide, the R group here will be negative and metal will be positive. Likewise, in Grignard reagent also, R group is negative, which is attached to the magnesium, that will be positive, that is attached to the halogen there. So here magnesium positive, R group negative, and in organolithium, lithium is positive and R group is negative. So anyway, in both cases, R group act as the negative, and that will be the very strong nucleophile. Strong nucleophile, and that is what will do the reaction there. Now the question is, first of all, how do we prepare Grignard reagent or the organometallic reagent, organolithium? And the second question will be